Video, we're going to look into how to implement a simple multiplexer. A multiplexer, as the name implies, is drawn something like this. So what we have is multiple inputs. We have input A probably, input B, then we would have something like a select line. So, and we have an output. So for example, what we are saying here is this is how it works here. If my select line is 0, right, my what input is connected to 0? A. My input A goes down, goes to the output. And if my select line is logic 1, right, what input is connected to 1? B. So B is connected to the output. So basically what we are saying is my output equals A if select line equals 0, and my output equals B if select line equals 1. So multiplexer is a simple design that takes multiple inputs and connects my input to the output based upon your select line. So here my number of inputs is A and B, right? A and B are primary inputs, so 2. So that is why we call this a two-way multiplexer. Now when we have inputs A and B and select line S, so we have total of 3 inputs, right? So that is the reason I have a truth table here for 3 columns and 1 output. So as you can see, my select line, when my select line is 0 here, as long as my select line is 0, see what is my outputs here? 0, 0, 1, 1, right? They're exactly the same as my outputs. So my output A, input A is connected to output B. On the other hand, when my select line is 1, see here, my input B is 0, 1, 0, 1, and my output is exactly the same. So when my select line is 1, my input B is passed on to the output, right? So if from this, if we derive the logic function, my output is going to be equal to SCL bar times A plus SCL times B. And this SCL times A, we have seen that before. This is A, and that is SCL. Sorry, I should have drawn a better inverter there. No, there we go. That is a better looking inverter. A, select line, and B, and that is connected to my output. That is your two-way multiplexer. So what if we have inputs A, B, C, and D? We have, that is what we call a four-way multiplexer. So if we have four-way multiplexer, so now see here, I have A, B, C, and D, right? So, and I have my output. So how do we derive this? Now let's look here. To select between 2 inputs, I use my select line. So I used 1 bit, and how many combinations did I get? 2. For 1 bit I have 2 combinations, which could I use for input A and B. So now I have 4 combinations here. If I need 4 combinations, how many inputs do I need? With 1 input, I get 2 combinations. With 2 inputs, I get 4 combinations. So the number of select lines should be 2. Yes, should be S1, S0. So from here, what we are saying is for 0, 0, 0, 1, 1, 0, and 1, 1. So your function output would be something like S1 bar, S0 bar A plus S1 bar S0 times B plus S1 S0 bar times C plus S1 S0 times D. This is your 4-way multiplexer function, right? So how do we derive a circuit? If you see here, I have 4 inputs A, B, C, D, then 2 input select lines S1 and S0. That is total of 6 inputs. So if you derive a truth table, that is 2 to the power of 6, 64 rows. That is way too many, right? So let's look here. Now, if I look into these 2 functions here, can I look into these 2 and look into these 2 here? So I have, can I factor out S1 times S0 bar A plus S0 times B. Similarly, I have S1 times S0 bar C plus S0 times D, right? So now for this design here, so what I'm saying is for these, if I implement this function here by itself, this function by itself, can I implement using a simple what I'm going to do here is going to implement that with a 2-way multiplexer, implement this with a 2-way multiplexer. So let's look here. I have a 2-way multiplexer, S0, input 0, 1, connect A, B here. Similarly, I have input S0, it's the same input, right? So I'm going to take that, connect it here, C and D, put 0, 1, right? I have 2 outputs coming out. So you implemented this function using 2-way multiplexers. I have this output. Now if you see this overall function, and this overall function, let's say if these 2 are 1 inputs, we got this. Now we have 1 select line, we have to pass this signal if my S1 is 0, and we have to pass this signal if S1 is 1. So what I can do is I can implement a 1 more cell multiplexer here, and I'm going to give S1 here, input 0 and input 1. We'll call this out. So my S1 0, if my S1 is 0, my first product term is being passed. So bring that, connect it to there, 0 is being passed. Now if my S1 is 1, the second product term is passed. So the S1 is 1, so the second product term is passed here. So if you want to design a simple 4-way multiplexer, all what you need are 3 2-way multiplexers here. Okay, with that I will stop, and we will talk more about this during class.